um, part a combinational circuit. What do you mean by combinational circuit? You have there the adder, okay, the subtractor. What else? You have the decoder, encoder, decoder. You also have there the multiplexer and demultiplexer, demux and mux. Okay, but this time with added element, which is the memory element. So, for example, a counter, counter is an example of a sequential circuit. So what happens when you have the counter? So you start with 0, okay, so 0 plus you have an adder, okay, 0 plus 1, and that becomes 1. Okay, so this previous answer, so this particular output is another input. So there's a feedback going to that combinational circuit. So this one plus 1, and that becomes 2. So this 2 again is a feedback here, which added to the value 1 and gives you number 3. So basically, it makes use of a feedback or a memory element, which is an input to the combinational circuit. Okay. So what are the two types of memory element that you can use for the sequential circuit? So you can do either a latch or a flip-flop. Okay. So what's the difference between the two? So in a latch, it makes use of a enable input. So it has an enable input, which means you use a level triggered value. So you have here a level triggered clock. In flip-flop, on the other hand, okay, so it makes use, so there are two types of flip-flop. You have the synchronous and the asynchronous. Okay, so in this case, it makes use of the clock, and this either a an edge triggered clock, which means if this is your clock, okay, the content if of so positive edge, so you have here the positive edge, okay, so it will only change if your clock changes from low to high. Okay, so there will only be change if your clock signal goes from low to high. Okay, so from low to high. Then if you have also negative edge, okay, so which means this is your clock, there will only be change. So this particular content, the content of your memory, or the content, the output of, so the QN of your flip-flop will only change on the negative edge, which means from high to low. So it will only be triggered or changed from high to low, and so on. So, the first example of a sequential circuit, or first implementation, is the SR latch. SR, or what do you call this? SR latch, yes. So in SR latch, it can be constructed using a NOR. Okay, so it can be implemented using NOR, and of course using the NAND implementation. Okay, so in this case, okay, so as you can see, we have this circuit. So we have here the R and then the set as input, and whenever there's a latch, okay, so you have a output Q and its complement. Now, so if you will be considering this output, so you have the OR. How do you the truth table of your OR? How do you get the truth table? So say you have A and B, and you have an output Y. So in this case, what will be the values? 0, 0, 0, 1, 1, 0, and 1, 1. So since that is a NOR, so 0, 0, 0 or 0, that will be 0, and complement that will be 1. So 0 or 1, that this will be 1, complement is 0. So 1 or 0, that is 1, complement is 0. 1 or 1, that is 1, complement is 0. Now, so as you can see in this case, so how do we get this given value? So say in case 1, okay, So in case 1, say we have here R is equal to 1 and S is equal to 0. What will be the value of Q and the Q bar? So in this case, as you can see, if we have here an input of 1 and R is 1 and S is 0, okay, so as you can see, whenever there's an input of 1, okay, the output is 0. Okay, so in that case, 1 or 0, so the output will be 0. Understood? So in this case, so since this output is 0, so you have here as input here of 0, so 0 and 0, so 0, 0, nor 0, that will produce a 1. So 0 or 0 nor 0, that is 1. So in that case, Q is 0 and Q bar is equal to 1. So say for example, we remove the input. So what do we mean by remove an input? So we set that R is equal to 0 and S is equal to 0. So in this case, so I'll change the color. Okay, if R is equal to 0, now I'll just delete so that it will be clearer. So for the second case, okay, say you have here R is equal to 0 and S is equal to 0. Okay, what will be the value of our Q and the I? So as you can see here, if you have 0 and 0, 0 nor 0, what will be the output? What will be our output here? So if we have a value that is 0, 0 or 0, so 0 or 0, so this one will become 1. So this goes here, 0 or 1. So our reset, and that becomes what? 0 or 1, that is equal to 0. So as you can see, Q is equal to 0 and Q bar is equal to 1. So what does it mean? It means that it saves or it serves as a what? It serves as a memory. Okay? So that serves as a memory. So say for example, we have case 2. Wherein in case 2, we set our R as 0 and S is equal to 1. What will be the value of our Q and the Q bar? Excuse me. Excuse me. So in this case, we have here Q. Okay. So in this case, we have R is equal to 0 and S is equal to 1. So as you can see, whenever there is a value of 1, what does it mean? It means that our Q is equal to what? Is equal to 0. So if this is 0 and this is 0, so 0 nor 0, that becomes 1. So our Q is equal to 1 and Q bar is equal to 0. Now, what if we remove the inputs, which means R is equal to 0, S is equal to 0? What will be the value of our Q and the Q bar? So in this case, so let's clear out our input. So in this case, we have 0 and 0, so 0 and 0. So if we have 0, okay, so the previous value of here is 1. Okay, so we have here, if we have 0 and 1, that will be how much? If we have 0 and then the previous value is 1, so 0 nor 1, that is equal to 0. So our Q bar is 0. And if this is 0, again 0, so our Q is equal to 1. Okay, so again, what does it do? As you can see, it saves the content, which serve as the memory. Okay, now for case 3, okay, so for the third case, so we have here case 3. So this time, if R is equal to 1 and S is equal to 1, what will be the value of our Q and the Q bar? So this is a little bit confusing because actually this particular input, this given input does not, it gives you a false statement or false value. So say for example, we have here 1 and then 1. So as you can see, whenever you have 1, okay, so whenever you have 1 and 1, what will be the value of of your Q? So Q is equal to 0, okay? And then whenever you have 1, so this is 0, so 1 and 1 nor 0, still that is 0, so it is not the correct way, right? Since it should be a complement. Okay, so you have here is equal to 0 and this is equal to 0. So actually, which means your Q is equal to Q bar, which is basically false. Okay, so what if, say for example, we reset that? So R0, S is equal to 0, we remove the input. Okay, so let's remove the input in this case. Okay, we have this given. So if we have this, so R is equal to 0, S is equal to 0. So in this case, what is the previous value? That is 0. So 0 or 0, so this will become 1. And 0 and 1, this will become what? This will become a 0. Okay, so as you can see, this is Q is equal to 0 and Q bar is equal to 1, which is basically the same like this. So it gets the memory. Okay, it serves as a memory. So that means if you have an input of 1, that is forbidden. So you're not allowed to use that particular value. Okay, that particular input. So that is SR is equal to 1, 1. Okay. Now, so let me just clear this one. Now, so for the SR, okay, so so this is the given truth table of the ASR. So let's see the characteristic table. So we have here the characteristic table. Characteristic table. So what do we have in the characteristic table? So we have there a given input or Q, which is the present state. So this serves as its present state. In some book, that is also given as Qn. Okay. Then we have here the input S and R. And then we have the next state with it, which is Qn plus 1. Okay. So okay, so if we have this given input, so 3 inputs, how many combinations do we have there? So we have 0, 2, 3, 4, 1, 2, 3, 4. So we have 0, 0, 1, 1, 0, 0, 1, 1. So for R also, we have 0, 1, 0, 1, 0, 1, and 0, 1. Now, so what will be the value of our, so let me just put a line here. So that it will not be confusing. Okay. So at this particular point, so what will be the value of our Qn plus 1? So as you can see, whenever you have an input of 0, 0, okay, so that means it is a memory. Okay. So whenever you have an input of 0, okay, so that it serves as a memory. So if you can, So for the truth table of the SR, so whenever you have SR that is 0, 0, 0, 1, 1, 0, and 1, 1, your Q will be equal to what? So 0, 0, this serves as a memory. Okay, so this is set, so that is 0, so this is 1, and this is unused. Okay, so as you can see here, whenever you have 0, 0, so whatever the content will, whatever the Qn, that will still be your Qn plus 1. So which means that is equal to Qn, and that is equal to 0. So it's the same. So Qn will be the, whatever the content. So you have the 0. So if you have 0, 1, so your next state will be 0. So if you have 1, 0, your next state will be 1. And if you have 1, 1, that is equal to x. So again, if you have 0, 0, whatever the previous state, so that will become 1. If you have 0, 1, it will be 0. If you have 1, 0, that will be 1. And if that is 1, 1, that is x, or don't care. So, and for the excitation table, so excitation table, so in this case, what do we have here? So in the excitation table, you have the present state and the Qn plus 1. So we are, so so this is our output. So for our output here, we will get the SNR. Okay, SSR. So in this case, what are the possible combinations if we have, so if we have this 0 and 0, so as you can see here, if we have 0, so we have 0, 0, 0, 1, 1, 0, and 1, 1. So if we have 0 going to 0, okay, so previous state is 0 and the next state is 0, what is our SR? So as you can see, SR is 0, okay, S is 0, and R is, it changes from 0, it's either 0 or 1. So we have here, don't care. Okay, so if we have on the other one, present state 0, and next state is 1, so what's that? We have present state 0, and next state is 1. What will be our trigger? What will be our excitation table? So that will be S, so that will be 1, 0. How about if we have 1, 0? So what are those? What is that actually? What is that? So we have input 1. Okay, so present state is 1. Next state is 0. And what is that given? We have 0, 1. So I have your 0, 1. Change ko na. So that is, we have 0, 1. And then for 1, 1, so for 1, 1, how many do we have for 1, 1? So from 1, 1, okay, and this, what is that? We have a consistent of R, and the S is don't care. So in that case, we have X, and what is our R? That is 0. So that is the excitation table for the sequential circuit SR, for the SR. So we have here SR latch. Okay. Okay, so we will be continuing with the next